So this week we're going to be looking at ratio and proportions. This unit is going to be divided up into two sections. So the first lecture being today, Monday, May 11th, and then the second lecture being Friday, May 15th. So this is part 1, and this is out of Unit 5 in your textbook. Alright, so a ratio then is basically a relationship between two numbers. And proportions are two or more equivalent ratios or fractions. And I'll explain that here in just a second. So when we look at proportions, we're basically comparing two equal ratios in a mathematical equation. You're going to have to bear with my crude drawing again. The Microsoft Surface Pro, even though I liked writing on it better, it actually took 21 hours to convert from a PowerPoint to a video, and it was just very nerve-wracking. So we're going to look at this piece of a pie here, a whole pie. Okay, so when we're talking about, let's see if this is going to work. So a ratio, let's say we cut this pie into 4 parts. Okay, sloppy cutting. Okay, but supposedly this is 4 equal parts. Okay, so 1 dot dot, that's the dot dots, to 4. Okay, so we have 1 piece of pie eaten out of 4 pieces. Okay, and so you might recognize that also as a fraction. So it basically means the same thing, it's just written differently. Okay, 1/4. Okay, so if we were to divide our pie into 8 sections, let's say we had 8 pieces of pie. Pretend here's a line here. Okay, looks like a spider. Now we have 2 pieces missing. So we'd have 2 to 8. Okay, that is an equivalent proportions. Okay, or equivalent ratios. Okay, so those are an equivalent ratio. They're basically the same thing because 2/8 can be reduced down to 1/4. Okay, so that's how we write ratios. We write them out like this. Okay, so you're comparing a part again to a whole. Okay. All right, next page here. So this is kind of how I'm trying to write it. So 3 is to 8. Okay, so we can write it with the 3 dot dot 8, or a fraction 3 on top and 8 on the bottom. And ratios should be reduced to their lowest terms. Ratios basically are fractions, again, that represent that part to whole relationship. So another thing to look at for an example is if we are comparing to how many hours of sleep in a 24-hour day. So we have 8 hours of sleep to a 24-hour day, or 8 over 24 in the ratio, in the fraction, the way we write it, and then reduced to 1/3. Okay. So I think that's fairly straightforward. Simplifying ratios. Now I do have, this is an example here, and page 131 does a pretty good job of explaining there towards the top of the page, and then on page 131 you also have practice 2, you have homework for that page. And let me take a look really quick here. 131, it's 1 through 10 all. So when I'm done here with talking about this, we will actually work through one of those first problems there. Okay. Alright, so here is kind of an example of what you need to do. So you're going to be presented a simplifying the ratio. Okay, simplifying the ratios is an important skill, so we need to make sure that we know how to do this. So we're going to look at our first number here, which is 4.5. Okay, and we're going to change that mixed number being, remember, a whole number and a fraction. We're going to change that to an improper fraction. So 4 1/2 is the same as 9 over 2. Sorry, these aren't written with a straight horizontal line, but so you take your 2 times your 4, which is 8, plus your 1 gives you 9, and that's where this 9 comes from, and then over the denominator of 2. Okay, so that basically changes 4 1/2 then to 9 over 2, and then so in the book they actually have this is written as the ratio sign, not the division sign, but remember it's basically the same thing. Okay, I love my sloppy dots. So in the textbook it's actually written with the dot dot. So 4 1/2 to 6 basically. Okay. So we're going to go ahead then and do the 6 over 1 because it doesn't change its value, it's still 6. Okay, so 6 over 1, and remember when we're working with division we're going to flip that second number. Okay, so we flip the second number, so we're going to flip the 6 over 1 to 1 over 6. So now we're just going to go ahead and multiply across. Okay, so we can say 9 over 12, which is what we get here, which then can be factored out further or reduced to 3/4, because both 9 and 12 are divisible. That's how I do it, are divisible by 3, and then that gives me 3/4. Okay, which then is 3 to 4 is your simplified ratio. Okay, so you want to write out your answer as a ratio. Don't put it in the fraction format. Okay, make sure you guys are reading your directions. I've been pretty lenient on taking improper fractions and maybe not reducing all the way, but try to take it that step further. Alright, so we're going to go ahead and work through, I'm on page 131 now, and practice 2. Problem number 1, okay, and it's saying 24 to, these are my little dots, to 3 1/4, okay, equals. So the directions are: simplify the following ratios, write each answer as a ratio. Okay. Okay, so I can go ahead if I want to kind of write this out as a division problem. Then I can take my 24 over 1, because that's the same value. Okay, now I'm going to go divide. I'm going to change this now to an improper fraction. So 4 times 3 is 12 plus 1 is 13. Maybe a little bit better at this. Okay, so now what do I need to do to go on? I hope you're saying flip it. Okay, so I'm going to flip the second number. I'm going to flip that and change it to a multiplication problem. So I have 24 over 1. I have 4 over 13. Alright, so I multiply that out. Let's see, that should be 96. Because I went ahead and multiplied 24 times 4 is 96. 13 times 1 is 13. Okay. This actually, let me double check, but I'm pretty sure, because I've worked this problem out before and I actually have written in my book. Oops. See, I use my calculator to double check. Yeah. 96 cannot go into 13. I know that 13's a prime number, but I thought, well, maybe it can go into 96, but I can't. So this is part of my answer. It's my first step to my answer, but how should it be written? How should it be written? It should be written in the ratio format, okay? And your top number is your left number. Okay, so your top number is your left number. So we have 96 to, that's kind of how you say it, sorry, that really stunk. Let's see if I can erase that. 96 ... to 13. Okay, so the correct way to write this problem out is in the ratio format, because that's what the directions say. Okay, so hopefully that'll help you out, okay, with that particular homework assignment. So that was practice 2, page 131. All right, moving on. So this pretty much is telling you the same thing, using mixed numbers and ratios. Okay, so we had a mixed number. We went ahead, so we're comparing 2 1/3 days to 2 days. So write 2 1/3 days to 2 days as a ratio in lowest term. So we're going to do the same exact thing. We're going to change that 2 1/3 to 7/3. Okay, and they went ahead and just kind of did a division over, like here with that line. Don't get freaked out about that. Just like, okay, just go ahead. If you don't have to do this stuff if you don't want, if it's going to mess you up anymore, just go ahead and write it out to a division problem if you'd like, whatever makes sense for you. So again, change the mixed number to an improper fraction. So that's what we just did. We took the 2 1/3, changed it to 7/3, divided by 2. Okay, so this is basically like looking like 2 1/3 to 2. Oh my gosh, that was lovely. Okay, so that's pretty much the same thing, okay, as this. Okay. All right, so then we've got our fraction format here. We have 7/3. We have to flip the second one here. The 2/1 becomes 1/2. We're going to multiply straight across 7/6. Now this is bad because, well, this one isn't telling you to write the answer to a ratio, but if I did, if that's what my directions were, then I'm going to change that to 7. So your top number's on your left, your bottom number's on your right. So that's your ratio format. All right. So again, page 131 kind of shows you that. All right, now looking at decimals in ratios. How do we deal with that mess? Okay. If the ratio has decimals, move the decimal point to make the numbers whole. And remember, you have to treat both sides the same, okay? No discrimination here. You're going to treat them both the same. So we are looking at 7.26 to 2.31, okay? So we want to get rid of the decimal. And over here, to get rid of the decimal on the left side, you're going to move 2 places to the right, which means you have to do the same exact thing to the right side, okay? So this 2 could be replaced, remember, by ... okay? Or it could be written in a fraction format. Okay, so now we have 726 to 231. What they did here is they reduced it, and how they reduced it is both sides are divisible. Both sides are divisible by 33. Okay, that's how it's reduced, if you wonder how they got there. This is an example from the PowerPoint. So both sides then are divisible by 33. Okay, so that's how they got from 726 to 22 and 731 to 7. Or I'm sorry, 231 to 7. they divided both sides by 33. All right, moving on to equivalent proportions. Okay, equivalent proportions. So this is where we use that kind of solving for x, and that's kind of why we talked a little bit about the pre-algebra part first. Okay, so proportions then are two or more equivalent ratios or fractions in which the terms of the first ratio fraction have the same part-to-whole relationship as the second ratio or fraction. Okay, so for example, if one box of gloves contained 100 gloves, then 4.5 boxes of gloves would contain how many gloves? Okay, so if one box of gloves contained 100 gloves is equal to basically 4.5 boxes of gloves containing how many gloves? Okay, so you're solving for x here. Okay, so that way you can kind of know, like, let's say you're given, you know, that there's, you know, you can work the problem backwards if you'd like. Let's say you have 4.5 boxes of gloves and you have 450 gloves, but you need to order more gloves, so you really want to know how many are in one box. Okay, that is where I would see the problem being more useful, but this is kind of how it's set up, and I believe this is in your textbook too. Can't remember off the top of my head. Yeah, this is on page 135. Okay, page 135 is where this example is. Okay. So you're going to go ahead and you're going to cross multiply. Okay, so don't worry about all the wording and everything to mess you up right now. Okay, you can also change this here to a decimal to kind of make it easier. So 4.5 being 4.5. So then you would take 4.5 multiplied by 100 gives you 450, and then you'd only divide by 1 because that's how the math is with this particular problem. You don't have any other bigger numbers to work with. Okay. All right. Let's say let's say for fun I wanted to solve for this. Let's say I want to solve for that. Let's say I don't know what this number is. And I had it set up this way. I didn't plan on doing this, but as I was talking about it, I thought maybe I should. So 4.5 boxes, I'm not going to write out the word, you know what I'm talking about here. 4.5 boxes to 450. So what I'm saying is I have, to 4.5 boxes, I have 450 gloves, okay? But I really want to know how many are in one box, because I need to order more boxes. Let's say I need 1,000 gloves. Oh, I started writing without thinking. Okay, so I'm trying to solve for x here. So how would I solve for this x? I would do the same exact thing. I would multiply, cross multiply. I would 450 times 1 still is going to give me 450, right? Okay. But then I have to divide it by 4.5. Okay, so I have to divide it by 4.5 to figure out for x. And what do we know about dividing decimals? We want to get rid of this decimal. We're going to move 1 point over, 1 space over. So that means I have to move 1 more space over here and bring my decimal up to here. Ooh, this is going to be interesting. Don't have a lot of room. Okay, so 45 into 450. I mean, we can do the math pretty simple, but I'm just working through it just for the sake of doing it. 1, okay, goes into 45 one time. 45 goes into 45 one time, rather. If I were to do my subtraction, then I'd have 0. But that doesn't make sense. 1 times 45 is 450. I'd have to put a 0 here and a 0 here. Okay, so 4.5 times 100 definitely equals 450. So I know now that 1 box equals 100 gloves. Okay, long story there. Okay, so to test then to see if proportions are equivalent, you are definitely going to cross multiply and see if it is an equivalent proportion. So the next page of your homework assignment is on page 135, and it's saying, so if you're not sure how to do it, just write yes or no, or I know a lot of people are just writing in their book, which is actually really not a bad idea. It makes it really easy to grade. I love that when you guys are doing that. If you want to use your book, just go ahead and write in your book. Maybe write it on a piece of paper first, so you don't have to do a lot of scribbling on your book, and then that way you just have your answers written. Okay, so to test to see if proportions are equivalent, you need to cross multiply, and if they result in the same answer, then they are definitely equivalent. So if we are looking to see if 3 to 4 is the same as 15 is to 20, okay, so again, looking at it this way, and this is kind of funky here, but that's what that is saying, okay? That is asking if it's an equivalent proportion, okay, that kind of double dot deal there, okay? So it's asking me, are these equivalent proportions? Is 3 to 4 the same as 15 to 20, okay? Well, we can cross multiply and go, okay, I've got 4 times 15, that equals 60, okay, and I've got 3 times 20, that also equals 60. So yes, this is a proportion, okay, they're equivalent. Okay, now solving for an unknown using proportions, and here's that algebra piece again, okay, so solving for unknown in the proportions, and this will be actually then page 136 is the next part of your, actually you don't have to do 135, I'm mistaken, you don't have to do 135, don't worry about that. Just now you got 131, 132, and then 136, and then 137. So if you want to look at those to see, be my guest for practice, so you understand what that means, equivalent proportions. Okay, so now we're solving for x. Okay, so we got to figure out, how can I make this equivalent? Okay, what would be the number that I would need to put here that would make that equivalent? Okay, so we're going to cross multiply. I'm going to take 12 times 5, okay, that's going to give me 60, okay, 12 times 5 equals 60, and then this is kind of a, I guess, a drawn out way of doing it, but, and then I would divide that 60, oh my goodness, okay, so I would divide that 60 by 8 basically, okay, and that's basically what this is kind of showing, okay. Okay, 60 then divided by 8. So it's 5 times 12, 8 times x, that's what this is saying, okay. So now I have 60 on one side, 8x, okay. So I have to divide both sides by 8, so that cancels out the 8 here, so I have x equals 60 divided by 8, which is 7.5. Okay, so that's more the step-by-step way. And you do have those to figure out, and that is on page 136 then. And there's another example there too. Alright, so we kind of use this, like I was saying, one of the more common things that we will do is convert pounds to kilograms, okay? So you set up the problems like when you're using these proportions in healthcare, you're setting up these problems like fractions. So you're trying to solve for x basically. So one thing I do know is that 1 kilo or 1 kilogram equals 2.2 pounds. I have a person that is 61 pounds, 61.6 pounds. How many kilograms is that? Okay, so I have the known with the unknown, okay, and I'm going to put the same units across from each other, okay, so I have kilograms across kilograms, pounds across pounds, okay, And the reason it's important, all the medications are dosed, not only like what I was talking about tidal volumes and that, but a lot of medications are dosed per kilo. Okay. All right. Not so much our meds, but a lot of the other meds that are given. So on this one, it's the same type of approach. I'm going to go ahead and cross multiply my 61.6 times 1 still equals 61.6. Okay, and then I have 2.2 with my x. Okay, I need to divide by 2.2 to get rid of my x here, or to get rid of my 2.2 rather. Okay, and I need to divide it over here. So divide both sides by 2.2. That gets rid of my 2.2 here. If I do my math, divide each side by 2.2 to isolate x, I get 28 kilos. Okay. And on 137, you have what, 5 problems to practice that. You're going to be converting pounds to kilograms. Okay. Or kilograms to pounds. You're going to be doing both actually. You're doing pounds to kilos and kilos to pounds. So back and forth. Another blank. I think what I was thinking I could do here is do another one for you guys. So that was pounds to kilograms. How about kilos to pounds? Okay, so look at number 1 on page 137. So I'm going to convert back to pounds. I have 16.4 kilograms is how many pounds? Oh my gosh. I move this mouse sometimes and it just like goes out of control. Alright. And how many pounds is that? And sometimes it does really well. Or maybe not. Alright. So 16.4 to how many pounds? Okay, so that's actually number 1. Okay. So you're going to round to the nearest tenth too, because some people asked how far do I carry this out. Alright, so I'm going to do 16. Try to write a little bit smaller. Kilos. I'm going to put those next to each other. I want to know how many pounds is this. That's what I'm solving for, is x. Pounds, I better write. Okay, and I have 2.2. No, I have 2.2 pounds down here. Pounds is always the bigger number. So it always sounds better if you weigh yourself in kilos because it's less and it's a lower number. Alright. If that makes sense. This should be a 1 kilo. So that's my, this is my known. I know that 1 kilogram equals 2.2 pounds. Okay. And my kilograms are across from each other, my pounds are across from each other. I'm trying to solve for x. So in this situation, instead of dividing, I'm just going to multiply. 16.4 times 2.2. And if you'd like, you can use your calculator, okay? Just so that you know how to do it. I'm going to work it out for you guys. I'm going to drag you through the agony. Okay, times 2.2. Alright. Because I think it's good practice to know how to do this, because I know a lot of people didn't know how to do this before. Okay, I'm putting the 1 and the 1 here, because that's telling me I have one place value here and one place value here. It's like a little reminder that when I get my answer, I need to move 2 place values from the right to the left. Okay, so I'm going to just do my math here. 4 times 2 is 8. Okay, 6 times 2 is 12. Carry my 1, 3. I always put an x here. It's just how they'll put a 0. Again, 2 times 2, or 2 times 4 is 8. Oh, getting too fat there. 2 times 12, or 2 times 6 is 12. Okay, I have the 1 here from the 6 times 2 is also 12. 3 times 2, I mean, sorry, 3 times 1, oh my god, 2 times 1 plus 1 is 3. Wow, that really stinks. Okay, so I should have 8. I haven't worked this out yet. This is one of the spur of the moment things I guess I decided to kind of do. 10, 6, and 3. Oh, that's hideous. Okay, so it should be 36. What do I got? A 0 and an 8. So I move over 2 more desks to place values. So I could say 36.1 pounds. I'm going to get out my calculator now. I'm going to, I guess, cheat. 16.4 times 2.2. Yeah, I did it. 36.08. Okay, you can write out 36.08. That would be rounding to the nearest hundredth, or you can round it to 36.1, which would be to the 10th. All right, I think that actually is my last slide. So, wow, 31 minutes to talk about 13 slides, but math, you know, we spend a lot of time on the board and stuff in the classroom, which I desperately miss. I will schedule a tutor session for this week. Maybe tomorrow we can talk about it at the meeting, or I'm actually recording this Sunday evening. We'll talk about it, and I will see you all on Monday.